Hello boys and girls, this is Mr. Kizik, and in this video we're going to be looking at linear inequalities. So what is a linear inequality? Well, a linear inequality is similar to a linear equation, except it has an inequality symbol and shading, which we'll see what that is in a moment here. Another thing that's different about it is a solution to a linear inequality. So unlike what we've been talking about with the systems of equations where, there was one answer or infinitely many or no solution, a solution to a linear inequality is all ordered pairs that make the inequality true. And that's where shading comes into play here. But before we look at that, let's actually take a look at some examples of ordered pairs that may or may not work for inequality. So we talked about a little bit about this before in the beginning of the year. So if I look at the first one, 2, 5, is that a solution to the linear inequality that's written? So all we just have to do is just put in 2 for x, 5 for y, and see what we get. So 2 times 2 minus 3 times 5, is that less than 15? So 2 times 2, 4, minus 15, less than 15, is negative 11, less than 15. That works. So this is a solution. Let's look at negative 1, negative 7. So is 2 times negative 1 minus 3 times negative 7, is that less than 15? Well, 2 times negative 1 is negative 2. Negative 3 times negative 7 is positive 21. Negative 2 plus 21 is 19. Is 19 less than 15? The answer is no, obviously. So that is not a solution. So again, it's a solution. An ordered pair is a solution if it works for the inequality. So how can we represent it graphically? Well, graphing linear inequality is just a way to show all the ordered pairs that are solutions, so you just don't have to keep guessing here. So the steps to graph, step 1, you want to put the inequality in slope-intercept form. So remember, slope-intercept form is that y equals mx plus b. Now I put it in quotes because, remember, there's not an equal sign, it's an inequality symbol. So if you remember that one chapter we did with solving inequalities, those same rules still apply. So if I'm dividing or multiplying by a negative, you flip the inequality symbol. And then the next part is just going to graph the line as if you would for y equals mx plus b. And here's where the two parts are a little bit different. You actually could have a different kind of line here. You can have the normal solid line when the inequality symbol has these little lines underneath there. Remember those little lines being equal to. But you can also have a dotted line as an answer too, when the inequality symbol doesn't have anything underneath there. And then with this too, we have what I mentioned before, shading. So with shading, you're going to shade above the line for a greater than or greater than an equal to symbol. And you're going to shade below the line when it's a less than or a less than or equal to symbol. So again, the 3 steps. First step is to get in y equals mx plus b. Then if it's a solid, if it has a little equal sign underneath there, then it's a solid line. Otherwise, it's a dotted line. And then you shade above if it's a greater than symbol, or you shade below if it's a less than symbol. So let's look at this example problem, and then we'll look at a couple on the back too. So this example here does everything that we are required to do. We need to get in the form of y equals mx plus b, so we need to subtract 2x from both sides. We get negative 3y is less than negative 2x plus 15. And then we gotta divide by negative 3 on both sides. Now remember, I divided by a negative, so what happens? I flip the inequality symbol. And I have negative 2 over negative 3, which is 2/3 x. And 15 over negative 3 is negative 5. And now we're going to graph here. So where we start at negative 5, 1, 2, 3, 4, 5, 5 right here. And we go up to 1, 2 over 3, 1, 2, 3. Right there. So that's the same thing as always we've done before, but now we just have to determine what kind of line will we have here. Let's look at this inequality symbol. This inequality symbol doesn't have any lines underneath there, so according to step 2, this is a dotted line. So let's draw a dotted line. Now dash dotted, you'll see those two words interchangeable. And when you do these two, you definitely want to make your line go through your entire graph because of step 3 here, the shading. Again, we look at an inequality symbol, it's a greater than symbol. So since it's a greater than symbol, it means we shade above the line. So we shade above, and there you go. That's our answer. So you are required to do all that. You need to do the shading. And I always have students asking me, well, what's my answer? My answer is this graph right here. This dotted line, that's graphed correctly, and the shading. So basically, when you're looking for an answer, because sometimes it says, like on the keystones, can you pick a solution that satisfies this inequality? Anywhere that's in this shaded region is an answer to the inequality. Now, for a reason, I always have students picking a point near the line, and then they run the risk of getting it wrong. Pick a point that's clearly away from the line. Like, for example, 0, 0 would be a solution. Right? 0, 0 is right here. What's not a solution? Oh, well, negative 3, 5. 1, 2, 3, right all the way up here. Clearly in a shaded region. Now, is that the only solutions? No, because again, the solution is anything in the shaded region. So there's infinitely many solutions above there. So let's look at a couple more examples. So let's look at number 1 here. So first step, is it in y equals mx plus b? And it is. So we go about graphing it. So we start at negative 5 on the y. Okay. And the slope tells me to go up 1, right 3. Up 1, right 3. And then, hey, why not? Again, up 1, right 3. So on and so forth. Now we look at the inequality. There's no line underneath the inequality, so it's dotted. So we're going to draw a dotted line. The inequality is a greater than symbol, so it's shaded above. And there you go. There's our answer there. Let's look at number 3. Number 3, we need to get in the form of y equals mx plus b. So I need to subtract 5x from both sides. Subtract 5x. So I have negative 2y is greater than negative 5x plus 12. And then divide everything by negative 2. Y. And then we divide it by negative, so you know what that means. We flip the inequality symbol. And when we divide by negative 2, we get 5 over 2x minus 6. And now we can graph our solution. So we start at negative 6. 1, 2, 3, 4, 5, 6, right here. And then 5 over 2 says go up 5. 1, 2, 3, 4, 5 to the right 2. We can do it again. 1, 2, 2, 3, 4, 5 over 2 right there. Let's look at the inequality symbol. Inequality symbol says there's no line underneath there, so it's dotted. So let's draw a dotted line. And the inequality symbol now is a less than symbol, so that means you shade below the line. This is below the line. I sometimes have students asking which is above, which is below. Well, pretend you got the line and you got a little man walking on the line. Well, where's above him? It's above his head, is on this side right up here. And then below the line would be below him, which is right here. It's a corny way of thinking about it, but it is something that students have thought about in the past. Let's look at number 5. So number 5, again, we need in the form of y equals mx plus b, so subtract x. Negative y is greater than or equal to negative x plus 8. Still need to get y by itself, so divide by negative 1. And because, remember, I divided by a negative sign, or a negative number, I gotta switch to inequality. So x minus 8. So I start at 8. 1, 2, 3, 4, 5, 6, 7, 8. And then go up 1, right 1. Up 1, right 1, up 1, so on and so forth. But whatever, how many dots you feel like you need. And then you gotta look at the inequality symbol again. Now this time it has a line underneath there. So because it has a line underneath there, it's going to be a solid line. So this time I'm going to draw a solid line. Better than that. Hopefully you'll do. And then this one again is a less than symbol, so it's below. The reason why we have the difference between the solid and the dotted line, well, look at the inequality symbol. The dotted line, well, the inequality symbol doesn't say equal to, so you can't be equal to it. Whereas this one, the solid line, says you can be equal to it. That's the difference why we do solid and dotted. Sorry, just looking back there. All right, let's look at number 6 because I want to look at a line that's actually going to go down here for us. So if I subtract 3x from both sides, I would get 2y is less than negative 3x, and then divide by 2 on both sides. So y is less than, remember, you don't switch to inequality, you only switch it when you're dividing by a negative. Here we're dividing by 2, positive 2. And I'm left with 3/2 x. Alright, so here, where's my starting point? My starting point's at the origin, 0, 0. And then the slope tells me to go down 3, 1, 2, 3, and right 2. 1, 2, 3, right 2. Alright. Look at the inequality symbol. No line underneath there, so it's dotted. I'm going to draw a dotted line through my graph here. And it's below, or I'm sorry, it's a less than symbol, so it's going to be below my line. So again, where is it below? Below is right here. Because if I could pretend I have a little man walking on my line here, less than below, it's below him. If you got any questions with these examples we've been doing here, just go back and look at them again to see why we did what we did. Okay. Number 7 and 8 here. Remember, these are simple graphs, simple things to graph, but always confuse the students. Y is less than or equal to negative 4. Well, remember when we graphed y equals negative 4? That meant we had a line going through negative 4. Or, yeah, a line going through negative 4 on the y-axis. So 1, 2, 3, 4. So here's negative 4. So I got a horizontal line going through negative 4. But we just got to check what kind of line. It has a little line underneath there, so it's solid. So it's a solid line going through here. And definitely do it a lot better than I did there. That's not even... Actually, that's bothering me. Better. And it's a less than symbol. Now, this is not too bad because it still is above and below, right? Less than symbol, below. You can also think about it logically too. Y is less than negative 4. Think of a number that's less than negative 4. Oh, yeah, negative 7. Where's negative 7? It's below here. All right, and then the last one here, x is greater than 7. So remember, that means you have a vertical line going through 7 on the x-axis. So if I do that, 1, 2, 3, 4, 5, 6, 7. Oh, the thing moved on me. 1, 2, 3, 4, 5, 6, 7, right here. Now we need to look at the inequality symbol to make sure, or just to see what kind of line. So there's no thing underneath the inequality, so it's dotted. So dotted line. There you go. Now, always get the question, well, Mr. Kiesik, there is no above and below. There's only left and right. And you're right. Well, again, think of it logically. It says x is greater than 7. So think of a number that's greater than 7, like, I don't know, 10. Where is 10 in respect to 7 on the number line? Oh, it's on the right side. So I'm going to do to the right. If it was a less than symbol, then think of numbers less than 7. It's on the left. And that, ladies and gentlemen, is how you graph linear inequalities. So I would like you do, again, if you don't understand something, look over back on this video. But I would like you to, for homework, do the odd problems, just the odds, front and back. All right, and then we'll see. And of course, that page is not loading, but you know there is another page there. Front and back, and then we'll see next class how we did with it, if we need to continue or you can move on or whatnot. Okay? Again, if you ever have any questions, please feel free to ask me, email me. This is Mr. Kiesik signing off.